So we'll be finding the volume of a square or rectangular pyramid, also a triangular pyramid, and a cone. Alright, here's a couple examples we'll be working with. So square pyramid, triangular pyramid. This is a pentagonal pyramid. We'll take a look at number 3 as well. 1 and 4 are the same, and then 5 and 6 are both cones. We'll do one of those cones. Alright, so here's a couple problems to look at. Try on your own. Number 1, we have a square pyramid. All right, so the first piece I want you guys to get a little visual of what's going on here. So if I have, right now I have all these lines, all the edges of the pyramid all going to one point. So from the base here, it's all going, that one's going to that point, going into that point, to that point, and to that point. So they're all meeting up at that one common vertex. If I were to take all these lines and just straighten them out, right, so if I took all those lines and straightened them all out, then I can actually draw this and say that this is going to be the shape of a rectangular prism. Can you see the piece here? Right? So it went from a pyramid to a triangular prism. So all these pieces here are going to one vertex, making a triangular prism. So the formula for the volume actually relates to a rectangular prism. The rectangular prism is length times width times height to find the volume. Once this all goes to this, so as they're all going to this one common vertex, or this one common point, the formula changes ever so slightly. Rather than just length times width times height, it's 1/3 length times width times height. So ideally, if you had a cup in that shape of that pyramid here, and you filled it up with water, you would need 3 of those cups to fill up the entire rectangular prism. Okay, so that pyramid is 1/3 of that rectangular prism with all the straight lines there. All right, so we're going to focus on just the rectangular prism here. So what is the length, the width, and the height of this rectangular prism? What's my length and width? Length and width? Yep.
2 and 2.
Yep, so here's the length, here's the width, happens to be the same thing, which makes it a square. And then the height, careful with the height. The height's going to come from the top of the vertex, straight down, and always make a right angle. So that symbol right there will be a hint that that's going to be a right angle, and the height will be 3. It's all in terms of centimeters. So find volume equals 1/3 times length times height times width times height. Doesn't matter which order I multiply in. If I multiply 1/3 times 3, that's just going to give me 1, which just leaves me with 2 times 2, or 4 centimeters cubed, because we're talking about volume. The next example, this one's actually a triangular prism. Triangular pyramid. Okay, it comes to a point. The generic formula for volume is volume equals base times height. And for a pyramid, anything that all meets up at one vertex, it's just going to be 1/3 base times height, where that base is the area of the base, and the height is the height of the prism or pyramid. Okay. The height of the pyramid is probably the easiest piece to find here. Again, look for that straight line from the top of the vertex, coming straight down, making that right angle. So my height here is going to be what? Yep.
8.
Yeah, so that height there is going to be 8. So we know that h is going to equal 8 here. Question is, what is that capital B going to equal? So right now, in my volume formula, I have volume equals 1/3. I'm missing that capital B, and then times the height of the pyramid, which is 8. So what shape is the base that we're looking at? What's the shape of this base here?
Triangle.
Yeah, so the shape of the base is a triangle. And I still need the area of the triangle. What is the area of a triangle?
1/2 base times height.
Yep, 1/2 base times height. Be careful. The height I'm referencing here is just the height of that triangle. So I'm just going to draw that triangle separately, just so I don't confuse it. So the triangle that I'm drawing is that bottom triangle right here, which has a 9 going from here to here, which is that's my base of that triangle, and then it has its own straight line coming down, making a right angle, and that is that piece right there, which is 7. So the base of this one is 9, the height of this one is 7. Find that area. Area is equal to 1/2 times base times height. So 1/2 times 9 times 7 is going to give me 31.5 inches squared is the area there. I'm going to take that 31.5 and substitute that into my base here, my base formula of 31.5. And then lastly, to find the volume of this triangular pyramid, multiply 1/3 times 31.5 times 8, and I get an answer of 84 inches cubed. This one is a hexagonal pyramid. Hexagonal because it has 1, 2, 3, 4, 5, 6 sides on my base. The base is a hexagon, so this is a hexagonal pyramid. Again, the volume of any three-dimensional prism is base times height. As soon as you turn that prism into a pyramid, because all the edges come to a one common vertex, 1/3 base times height. So at our level here, we haven't found the volume of a hexagon yet, or the area of a hexagon yet, but in this case, it gives me that capital B. So we know what B is equal to. And then we also are given the height here. From the vertex straight down, makes that right angle, right? That's the symbol that represents right angle. So the height of this pyramid is actually just 5 meters. So now I have all the components I need. So volume is equal to 1/3 times base times height. Volume equals 1/3 times 30 is 10. 10 times 5, 50 meters cubed would be the volume of this hexagonal pyramid. At some levels in geometry, once you get to that level, you'll have to find the area of the base on your own, and then the rest of it too. Before, again, we have another pyramid. My base is not a square, it's a rectangle, so a rectangular pyramid here. But again, volume is going to equal 1/3 base times height. This is the base. The shape is a rectangle. This is the height of the prism, or height of the pyramid, excuse me. And that one's actually easily given here. Height is, again, from the common vertex, straight down, find that right angle. That height is 9 feet. Excellent. All right, so now we're going to worry about the base. So the base is a rectangle. We want the area of the base. So my rectangle area, I'm going to write it here on the right side, is length times width. What is the length? What is the width of the rectangle? What is the length and width of the rectangle? Yep. 8 and 5. Awesome. So area is equal to 8 times 5, or 40 feet squared. So back to my formula. Volume equals 1/3 times, I'm going to include my units on this one, 40 feet squared times 9 feet. So again, the base is the area, the height is what makes it three-dimensional, the height of the prism. Multiply through, 1/3 times 40 times 9. It's multiplication, it doesn't matter which way you multiply. What's 1/3 times 9? 3. 3 times 40, 120. And then your units, you have feet squared times feet. So feet squared times feet to the first, if you want to think about it that way, is going to be feet cubed. Because my 2 dimensions and one more dimension will give me 3 dimensions. So 120 feet cubed is the volume of this rectangular pyramid. The last picture here we have is a cone. Alright, and again, relates to a cylinder. If you were to draw these lines straight up here, and then technically you just have a cylinder. I'm going to take that piece, bring that there, and then voila, and then we have a cylinder. So a cylinder relates to the cone as well. So the volume of a cylinder from previous videos is pi r squared h, where the generic volume is equal to base times height, where the base is the pi r squared, right? The base of this is a circle. If I were to draw that in there, the base is a circle, that's the pi r squared, and then the height of the prism is the line that goes from here straight down and makes a right angle. Now we have this all coming to one point, one common vertex, like the pyramids. So the only difference here is we're going to add a 1/3 pi r squared h, and that will be the volume of a cone. So that means if you take these cones of the same radius and the same height of the cylinder, fill it up with water, pour it in here, you'll need 3 of them to fill up the cylinder. Okay. We have a radius, we have a height that's already given. The radius is from here to here, so the radius is 7.75. The height is also given, which is 15. And then if we plug in, we have volume equals 1/3 times pi times radius, 7.75 squared, times height, 15. We can write the answer in terms of pi, where we leave pi in the answer, but let's use 3.14 for pi as well. So we'll do both answers. One in terms of pi and one not in terms of pi. So if you take 7.75, so 1/3 times 15 is 5. And then 5 times 7.75 squared is going to be 300.3 rounded to the nearest tenths pi centimeters cubed. So again, if you just take 7.75, square it, multiply by 15, divide by 3, and leave the pi symbol there, that will be your answer. Or take that 300 point without rounding times 3.14, and you should get an answer of approximately equal to 943 rounded to the nearest tenths centimeters cubed. Oops, just joking. 940, not 23, but 943 centimeters cubed.